Alright, hello everyone. So in this video I'm gonna solve a special type of integration by parts problems. Okay, this is a special category, but it starts like a normal problem. So let's see. So first thing we need to do is we need to decide what is u and what is dv. Now still we can rely on the LIATE rule. Okay, so we have an algebraic function here and we have an exponential function here. So let's choose x squared to be u because algebraic functions come before exponential functions, and dv is everything else, 2x dx. Okay, alright, and then we have to find the derivative. Du over dx is derivative of x squared is 2x, so du is 2x dx. Now we want to find v. If you integrate e to the 2x, it's e to the 2x over 2. Okay, so we have all the tools that we need to solve this problem. Now let's use the formula. Formula is uv minus v du. Okay, so u is x square, v is e to the 2x over 2, minus v is e to the 2x over 2, du is 2x dx. Now what we do here at this point is that we try to see whether we can simplify this integral. So we can, 2 cancel out. So what we get is, let's see, x square e to the 2x over 2 minus, now I'm going to write this integral in red. I will explain why. X e to the 2x dx. So this is what we have. Now the last step of the integration by parts problem here is to integrate this. Now here's, look at this integral that we have to integrate. Is that a simple integral that we can solve really quick? Can we use basic integration there? No, right? It is still a complicated integral. Now that violates our purpose of using integration by parts, right? Because in the discussion that we have in the very beginning of this video series, we said that we started with a very complicated integral, and the purpose of integration by parts is that when we choose our u and dv smart, we should get a simpler integral here and we can quickly integrate it and be done with the problem. But that's not the case here. So does that mean that we have chosen u and dv wrong? Well, I can say that no, u and dv, the choices are correct. Okay, you relied on LIAT rule. The choices are correct, but let's see what's going on here. Now I will face the reality. The reality is that, well, I have to integrate this one way or another. So let's integrate it. Okay, now let me think that integral as a new problem. You have to integrate x e to the 2x. I will think it as a new problem, forget everything that happened. So let's start to integrate this one. Well, still we have to use integration by parts. Okay, so u is x because this is an algebraic function, this is an exponential function. dv is e to the 2x dx. Now let's differentiate. U over dx is 1 and du is then dx, and if you integrate this, we get v to be e to the 2x over 2. Okay, alright, so let's use the formula again. uv minus v du. U is x, v is e to the 2x over 2, v is e to the 2x over 2, du is dx. Alright, now here there's nothing to simplify, but it is an integral that we can quickly integrate. Oops, I am forgetting this negative. Now if you integrate e to the 2x, that's a basic integral. We get e to the 2x over 2. That new 2 and this old 2 here will produce 4 here, and plus arbitrary constant c. Okay, we were not capable of solving this integral that we started with, but we were able to solve this integral that we were left with when we were doing integration by parts. Okay, so what I'm going to do here is I'm going to replace this integral by what we found here, because that is the answer for that integral, right? So let's do that. So we have x square e to this 2x. I think that you see what's going on here now. Now I'm going to use parentheses here because I don't want to mess up with this negative. Okay, so x 2x over 2 minus e to the 2x over 4 plus c. Now this is the solution for what? to the integral that we started with. Now do you see what's going on? We had to do integration by parts within integration by parts. Integration by parts twice. So this is a special category, okay? So there are instances, and you can create many problems where you started with a complicated integral, but when you apply integration by parts, still you get a complicated integral, and still you have to use integration by parts to solve the problem. Okay, so we have this type of problems. But the beauty here is we started with an extremely complicated integral. But when we apply integration by parts, it's gave us a less complicated integral. Okay, we can think it at least in that way. Then when we apply integration by parts for the small part, what we end up is with a simpler integral, much more simpler integral. So we had to go like extra one step to get that simpler integral. So that is the special thing about this problem. Now let's try to analyze why exactly this happened. Okay, now see, let's compare the integrals that we integrated. We started with x square e to the 2x dx. I want you to see this, I want you to learn. Then what we integrated is x e to the 2x. Okay, then after that what we integrate was what? E to the 2x over 2. Now look at the three integrals. We started with x square, okay, and then it became x, and then it became nothing, right? It became a constant. So we had to do this integration until we lose x, until x vanish. Do you see that? Okay, that x square term vanish. Now in the process, e to the 2x never change. Now we choose our e to the 2x as always a dv, right? Because that's an exponential function. We will never get to choose our exponential function as u, because exponential functions are on the bottom of the LIAT rule. Now think what happens when you have always e to the 2x as dv. What you do is you keep on integrating it, right? And when you integrate e to the 2x, it's e to the 2x, it's keep repeating. So e to the 2x kept repeating as long as there's a x term in front of exponential term. Your integral is complicated. This is complicated because you have x square in front of e to the 2x. This is complicated because we had x front of e to the 2x. But this is not, because now you have nothing, because that x vanished. So we have to do this again and again until we somehow vanish this x square term. Do you see what I mean? Okay, so let me show you another example. So you may ask, like, you will be like, well, does that happen to always like integrals like x times e to the 2x or x square times e to the 2x? No, look at this one, x square sine x. Now foresee what happens, try to predict what happens. Let's do this problem. So we have an algebraic function, we have a trigonometric function. Sine x is also like e to the 2x, right, or e to the x, because when you integrate sine you get cosine, when you integrate cosine you get sine. See what happens now. My u is x square, right? My dv is sine x dx, of course, because I use the LIAT rule. Now du over dx, I want to do this quick, which is 2x. If you integrate sine x, you get negative cosine x. Du here somehow is 2x dx. Now you can predict the same thing is going on, right? Okay, let's see, let's use the formula. uv minus integral v du. U is x square, v is negative cosine x, and v is negative cosine x, du is 2x dx. So let's simplify that second integral, negative x square cosine x, this is negative plus integral 2x cosine x. Now see what we got. Still we have a complicated integral. We started with x square sine x, now we have to integrate x sine x. Still it is not a basic integral, right? It's x times cosine x, product of two functions. What do we do? Now you know what we do. Guess what? We will do the integration again, but we will take that smaller integral now, 2x cosine x, think it as a new problem and integrate using integration by parts. I lost words there. So u is 2x because LIAT rule, and dv is cosine x dx. If I'm fast, pause the video and try to do it by yourself, because that's the best way to learn. So if you differentiate 2x, you get 2. See, x vanished. I think you foresee what's coming. What is the integral of cosine? Sine x. So du is 2 dx. Okay, now let's use the formula. So uv minus integral v du. U is 2x, v is sine x, minus v is sine x, du is 2 dx. So let's have this 2 here, 2 dx. Now you can integrate this one without any help of special integration techniques, right? Because integral of sine is just negative cosine. So it's going to be negative cosine, this negative and that new negative will give plus 2 cosine x plus c. Alright, so now let's replace this in the place here. So the final answer is negative x square cosine x plus 2x cosine x, answer from here, plus 2 cosine x plus c. Okay, so see, we started with a complicated integral. So let's write it again. We started with x square sine x, right? And then what we got is to integrate 2x cosine x. 1x power loosed. Then what we integrate is 2 sine x. We went until we lose that x power. We did integration by parts within integration by parts. So that's using integration by parts twice. Okay, now I'm going to give you a special statement. Now, can we have problems where we have to do integration by parts 3 times? Now it's going to get fun, right? How about 4 times? Can you construct a problem? Let's not solve it, okay? Let's try to make a problem by ourselves. Tell me a one where you have to do integration by parts 3 times. X cube e to the x. First you will get x square e to the x. Then you will get x e to the x. Then you will get x ex. Okay, not exactly. I mean, I was just predicting. But that's the way it's going to happen. You have to use integration by parts again and again and again 3 times. How about this one? X to the 4 cosine x. How many times do you think you have to use integration by parts? 4 times. Yes, you guessed correct. Okay. Now that doesn't mean, now don't get this one wrong. Okay. That doesn't mean that you're gonna get whenever you have x to the power in an integral, you have to do integration by parts again and again until that power vanish. No. Think about this problem. Don't get that wrong. X to the 4 times natural log x. This integral you only do integration by parts once. Because why is that? So in these 2 problems your choice for u is x to the 3 or x to the 4. Okay, but here your choice for u is natural log x because it's a logarithmic function and it appears on the top of the LIET list. And natural log x and cosine x e to the x have a different behavior. E to the x, when you integrate you get e to the x, and if you differentiate you keep repeating it. If you differentiate or integrate cosine x you get sine, cosine, sine, cosine. But if you differentiate natural log x, it's 1 over x. Okay, and it does not have this repeating nature. And I mean, here the choice of u is different. Here the x to the 4 is going to be dv, so you will not have 4 integration by parts. You will only have a 1 integration by part, okay, to do here. So this type of a problem, you have this repeating integration by parts 2 times or 3 times. It depends on what you have here, depends on both, okay, not just x to the power. It depends on the next function you have. Okay, alright, so that's all what I have for this video, and in the next video we're going to see another tricky type of a problem, and hope to catch you there. Okay, bye bye.